Welcome back, welcome back, welcome back. A, subtracting mixed numbers. B, multiplying fractions. C, rounding to the nearest tenth. And then we have that irregular volume. At this point in time, you should have already completed your challenge questions. If by some crazy chance you did not yet complete your challenge questions, ladies and gentlemen, please pause the video and try to get these answers, and then try to learn from any of the mistakes that you might have made. So the first one, we're going back to what, October, when we really learned how to do this. Let's see if it's still in your brain. So 52.5 is what we have. So we write it on the top. Since we are subtracting fractions, we always make sure that we write the numbers up and down, right? Vertically. 18 2/3 was what we're taking away from 52.5. After you write these two things down, you kind of want to separate the fractions and the whole numbers. Now, you have a half, you lose 2/3, and a lot of you guys already know you can't do that because you can't take 2/3 away from a half because 2/3 is more than a half. How can you take it away? But before you can add or subtract any kind of fractions, you have to make sure that they have the same name, right? You can't take 2/3 from halves. You can't do that unless they have the same name. So you look at 2, you look at 3. The first number they can both turn into, 2, 4, 6, 3, 6. The first thing they can both turn into is 6. Now we got to figure out what 1/2 is as 6. Well, how many 2's make 6? 3. So the magic number is 3. 1 times 3 is 3. So 1/2 turns into 3/6. And then what about 2/3? Well, same thing. How many 3's make 6? 2. The magic number is times 2. Do it to the bottom, do it to the top. 2/3 turns into 4/6. Now we have a new problem. I have 3/6. I lose 4/6. It's illegal. You cannot do it. You can't take 4 from 3. So we have to go over to our whole numbers, and we have to say, hey, 52, how you doing, man? I need one of you. I need one of your wholes. Sure, man, you could have one of my wholes. What are you going to turn it into? Well, we're working with 6, so I need to turn it into 6. One whole is worth 6/6. Now I don't just have 3/6. I also have 6/6. So total I have 9/6. Oops, not 9/9, 9/6. And 9/6 minus 4/6 is 5/6. And then 1 minus 8 is illegal. So once again, I got to borrow. I got to say, hey, 10, I need one of you. Sure, you can have one of my 10s. It's worth 10 ones. So now I have 11. 11 minus 8 is 2. I'm kidding. 11 minus 8 is 3. And then 4 minus 1 is 3. So your answer there is 33 5/6. 33 5/6. Let's go to B. B, we are going to multiply fractions. We want 3/5 of 1/3. Of course, our answer is going to be smaller than 3/5. It's going to be smaller than 1/3 because we're taking 3/5 of a third, or we're taking a third from 3/5. So the answer is going to get smaller. Can you reduce first? Oh, yeah, you can. But let's pretend you don't know how to reduce. Then you just multiply across. 3 times 1 is 3. 5 times 3 is 15. If you have absolutely no idea how to reduce, then this is your answer. You're not going to see that in the multiple choice option. So you really need to learn how to reduce. 3, what numbers can count to 3? 1 and 3, that's it. Can you count any of those to make 15? Sure you can. You can count 3 to make 15. So 3 is your simplifier, we'll call it. How many 3's make 3? 1. How many 3's make 15? 5. So this answer is equal to 1/5. If you took a different route in the beginning and you said, oh, I could simplify first. They're both 3's. You just need a top and a bottom to have something in common. They're both 3's. You can simplify that to 1. You can simplify that to 1. Or reduce that to 1, reduce that to 1. 1 times 1 is 1. 5 times 1 is 5. You would have gotten 1/5 that way. No matter how you slice it, it's 1/5. Let's go to 34 7/500. First thing that we want to do when we round is know what the rule is. The rule is tenths. So that says, hey, I see that your number goes all the way to hundredths. I need you to stop it at tenths. Well, first we got to figure out what tenths is. Remember, there's a cheat. Write the number 10, put a decimal after 1. Tenths is the first place after the whole. So that means this is the tenths. So if we round it to the nearest tenth, that means nothing is allowed after. The question is it closer to 34.7 or is it closer to 34.8? Well, the first thing going away is a 7, or I'm sorry, a 5. So it's actually, if you were to draw like a mountain of 34.7 and 34.8, 34.75 is literally right in the middle of the two. It would be right in the middle of the two. And everyone always tells you, if it's right in the middle, you always round up. Okay. The easiest way to teach rounding is the first number going bye-bye. If it's a 5 or bigger, then round up. So the answer is 34.8. Now to everybody's favorite question, this guy right here. Where'd my screen go? Oh no. Here it is. All right, the first thing that we have to do is cut it somewhere. You can either cut it down like this, or you can cut it sideways. Either way, you want to make it into two normal figures. I'm going to cut it down like this. Now I just have to make sure I have all my numbers. Let's see here. If this is 13 up here, that means this is 13 right here. So I have my 13, I have my 5, I have my, well, 16 doesn't matter, right? Not for this figure over here. The only thing I don't have is whatever, how far it goes back. Well, that's the same as whatever's here, which is the same as here, which is the same as here, which is 4. 4. So I want to find this area, because it's the area of the base. 13 by 4. Well, what's 4 times 13? See my paper here. 13 times 4. It's 52. So the area is 52. And then how far does 52 go up and down? 52 goes up and down times 5. 5 times 2 is 10. 25, 26. So that answer is 260. So this has a volume of 260. Now I got to figure out this volume over here. I don't have many numbers. I know this is 4. I know this is 8, but I need to know this. And it's the same as this, and it's the same as this. Ooh, okay, I see what I can do here. If this whole thing up here is 13, and the whole thing down here is 16, that must mean this is 3, which makes this 3. And if this is 3 and this is 4, then the area is 12. And 12 goes up and down 8. So 12 times 8. Twelve times 8 is 96. So I take this volume, which is 96, and I add it to this volume, which is 260. So 260, 96. 6 plus nothing is 6. 9 plus 6 is 15. And 2 plus 1 is 3. So the whole thing has an area, or a volume of 356, and it's in inches. So it's 356 inches cubed, because it's 3-dimensional. It is volume. Cool? All right. Let's move on. What are we doing today? Today we are classifying triangles. This is the last piece of the puzzle, ladies and gentlemen. This is the last piece of the puzzle. So here we go. First, let's review real quick. Captain Hook, can you help us review? What's a polygon? Well, if you look it up on Google, a polygon is a plane figure with at least 3 straight sides and angles, and don't worry about the typically 5 or more. So well, let's see what that looks like. Well, first, what is not a polygon? What is not? Well, all polygons have straight sides and they connect. This is not a polygon because it curves. And this is not a polygon because it is open. So polygons are shapes that have all straight sides and they connect. Let's go over here and look at convex versus concave. So it says, I can't see because my friend here is in the way. So concave is like caved in. The way that I was taught concave is you could put kind of a point in one area, a point in the other area, and if you make a straight line, you're both in the figure and out of the figure. Convex, you don't have that, right? Convex, you can't make one point one place and then a point the other way, connect it, and then you're in and out. There's nowhere on it that you can do that. So this is an example of concave because it's caved in. This is a convex because it's the opposite of caved in. Cool? Cool. Now let's just kind of look. That's why she's there. She was waiting to chill in the octagon. Get it? Here's a couple examples of some polygons here. We have 3 sides. 3 sides is a triangle. We have 4 sides. 4 sides is a quadrilateral. We talked about that. Your brain's going to want to say square, but 4 sides is a quadrilateral. Now that we have 1, 2, 3, 4, 5. 5 sides is a pentagon. We have 6 sides over here. 1, 2, 3, 4, 5, 6 is a hexagon. We have 1, 2, 3, 4, 5, 6, 7 is a heptagon. Everyone remembers octagon, right? Nonagon sounds like 9, so that one's a little easier to remember. And then we have decagon, which is like decade, which is 10. So in my mind, very easy to memorize, the pentagon, hexagon, heptagon get a little bit more confusing. Octagon's easy, nonagon, decagon. So the pentagon is like the pentagon in America, right? It's 5 sides, so that one's easier out of the 3 to remember. And then hexagon, you just got to figure out a way, maybe because it has X, and so does 6 has an X in it. However, you need to remember it. And then hepta, I don't know how you're going to remember heptas being 7, but you can just remember heptas being 7. Now let's talk about the triangle. Oh. I'm not going to do any Darth Vader right now. So what is a triangle? A triangle is a polygon with 3 edges and 3 vertices. And it is, remember, vertices is a fancy way to say corners. Is one of the most basic shapes in geometry. Perfect. We know what a triangle is. So there are 2 different things you can focus on when you are naming a triangle, right? You can either just focus on if these sides are different lengths, right? This one, it looks like all the sides are the exact same length. Maybe not. Maybe this one's shorter. Maybe this one's shorter and these are the same. That's one way to name what kind of a triangle it is. Another way is to focus on these 3 angles, right? Because every triangle has 3 sides and every triangle has 3 angles. So those are your 2 ways to name, to classify triangles. Let me tell you, classifying triangles is a lot easier than classifying quadrilaterals, okay? So this is the way that I remember how to classify triangles by sides. So you have 3 options. All 3 sides can be equal in length, right? This is option number 1. Well, what happens if one's different? Well, that's a different option. If one of them is a different length and then the other 2 are the same, and then there's only one other option, every single one is a different length. Usually when everyone's a different length, they go like this, and then they'll go like this, and then they'll go like this to show you they're all different lengths. See how these both have 1 line through them? That tells you that they're the same. All 3 of these have 1 lines. That tells you they're the same. And usually they'd probably throw 2 lines in this one to tell you it's different. So here's the way that I remember how to classify triangles. If they are all the same, then they are all equal. So that one's easy to remember because if they're all equal, then it's an equilateral triangle. It's an equilateral triangle because they're all equal. Simple, right? Now you got this one over here. So back in my day when we used to play basketball, and then if we were on a team and we knew that our guy was better than their guy, we'd say, come on, man, you can't take him on. Why don't you guys go ISO right now? You guys go ISO. And what ISO means is that we would just let you guys go. Like everyone thinks LeBron's as good as Michael. So we would just say, let him go ISO, let him go ISO. It just means we're going to let him go one-on-one. Everyone else just kind of stands at the court and they just let the two of those go at it. If you got the better guy, you know that you are going to win, right? Your guy's going to score. So it benefited you to go ISO, ISO. So if two of them are the same, I remember isosceles because of ISO, ISO. Let the two be the same. Everyone else, we're different. Let's back away. And then the third one, I don't know why I think of it like this. It's just like, oh man, you're all different lengths? Man, that's some scalene looking like stuff right there, right? So scalene's like Jafar's face, right? With that wicked looking beard. It's scalene. I know, it's a goofy way to remember it, but I kind of have to rely on goofy ways to remember things because my brain just doesn't capture these memories. Like other people can just remember all kinds of random things. I got to come up with weird ways to remember things so I don't forget them. So scalene's all three different sides. Isosceles is two of them are the same, and then equilateral is all three of them being the same. Now let's go into the other way to remember, the other way to name triangles, okay? The other way to name triangles. By their actual angle. So before we go into the three different options here, let's review angles. So a right angle is like every angle's dream. Like, oh my gosh, I just want to be right. I want to be exactly 90 degrees. That is a right angle. Right angle means 90 degrees. And then the symbol you see for a right angle is they always put a little tiny little square in the corner saying, this is a right angle. Now, you can either be bigger than a right angle or you can be smaller than a right angle. If you're smaller than 90 degrees, you're such a cute little angle. If you're bigger than 100 or bigger than 90 degrees, you're obtuse angle. Now, this is a fun little fact that maybe you did not know. No matter what your triangle looks like, if you add the three angles together, whatever their measurements are, every single time they will make 180 degrees. So there's so many. I mean, I would argue there's infinite different angles you can have inside of a triangle, right? But what happens is they're all sharing that magic 180 number. So if this one gets bigger, these two are going to get smaller. So here's the thing. You have, if every single angle is smaller than 90 degrees, it's still possible to make 180 degrees. If every single one is smaller, it's still possible to make 180 degrees. 80 degrees. So what do we call it when everyone's smaller? We call it an acute angle. Yeah, it's a acute triangle. What if only one is bigger than 90 degrees? Well, if only one is bigger than 90 degrees, then that angle is obtuse. So it only takes one angle to be bigger than 90 degrees to call it an obtuse triangle. Well, Mr. Stahl, what happens if two angles are bigger than 90 degrees? Nothing, because it's impossible. If two angles themselves are 90 degrees, it would be 180. But what would connect those two angles? Every triangle has to have three angles. So it's impossible to have a triangle with more than one obtuse angle. That's why it only takes one obtuse angle to make an obtuse triangle. And then last but not least, what do you think's in here? It's a right angle. One right angle is a right triangle. So that's pretty easy to remember. You're looking for anything that's not acute. If there's an obtuse angle, it's called an obtuse triangle. If there's a right angle, it's called a right triangle. And if there's not an obtuse or a right, then it's an acute triangle. All right, let's put this knowledge together right quick. Let's name this. Now, the only thing that we didn't really talk about is you want to put those two names together. So you want to focus on the sides, focus on the angles, and then that is how you name a triangle. So first, let's look at the sides. It's telling us they're all 5. Well, if all 3 sides are 5, then it is an equilateral. It's an equilateral triangle. Now look at the angles. Every single one is smaller than 90 degrees. So we call that acute. So put them together. All right, don't mind this anything. If you put them together, we would call that an acute equilateral triangle. And we have a perfect picture to represent acute triangle. All right, I am actually going to stop it there because this took a little bit longer than I expected. And then we will go over the questions together. We have an apple right here. Let's just use apple as a, hey, Mr. Stahl, I paid attention today. Okay? All right. I'll see you guys at the live session at 10:30. Bye, guys.